Okay, hi. We'll be doing a presentation on the preparation and crystallization of aspirin. This is Fu Ming, I'm Gabriel, and this is Hong Te. Okay. So now we'll be presenting to the CLS Learning and Sharing Festival Organizing Committee, and we are in the School of Chemical and Life Sciences, and we'll be sharing for the Learning and Sharing Festival. Okay, now I'll pass my time over to Hong Te to talk about this.
Thank you, Gabriel. Okay, so today I'll be talking about a few processes. Okay, firstly is the hypothesis of the experiment, purpose of experiment, theory of aspirin, history of aspirin, and the esterification process. Okay, so first, what is our hypothesis of the experiment? Our hypothesis of the experiment is that the synthesized aspirin will have a temperature range of 1 degree Celsius, which will mean that the aspirin is pure. Next is the high yield of our aspirin is due to the procedures being carried out without any problems. The experiment is considered successful when the aspirin obtained is pure, and lastly, the aspirin that we obtain will be a white solid. Next is the purpose of the experiment. Firstly, we need to synthesize the aspirin. Secondly, we need to recrystallize it to obtain the pure aspirin. Next, we need to determine the melting point of the purified aspirin by using the melting point equipment. And we will furthermore refine the synthesized aspirin. Lastly, we will classify the synthesized aspirin to its different categories based on its temperature. Next will be the theory of aspirin. So what does aspirin do? Aspirin helps to relieve pain, inflammation, and fever for people. Okay, so there are two enzymes that are present in the body, which are COX-1 and COX-2. These enzymes produces prostaglandins in the body, which causes the body to feel pain and inflammation and fever. So aspirin furthermore inhibits the clustering of platelets, which will therefore decrease the viscosity of the blood. It furthermore prevents formation of blood clots, which causes heart attack. Next is the history of aspirin. So you might wonder, where does aspirin come from? Aspirin was first found from Spirea, which is a type of plant, and the Spirea contains the main ingredient, which is salicylic acid. It was first founded in the 18th century by Edward Stone. And next is Hippocrates, which was a Greek scientist. He founded the main ingredients which are present in the willow leaves and barks, and he said that those are the ingredients which are used to treat the fever and inflammation. Henry Leroux and Hermann Klopp furthermore discovered synthetic salicylic acid, which was then used to form acetyl salicylic acid, which is the aspirin, during the late 1890s. So the background of the aspirin is that it is an over-the-counter drug. Anybody can obtain it without any prescriptions from the doctor. It is a non-steroidal drug which will not affect the hormonal balance of the body. Furthermore, if aspirin is taken with other medicines, it will make it less effective, or in some cases even harmful. Aspirin can cause some side effects, for example like indigestion or heartburn. Next is the esterification process. So what is esterification? Esterification is a process of forming esters from carboxylic acid and alcohols. And how is it important? Esters are mainly found in natural occurring fats and essential oils, and are also used in many products to give its aroma and smell. For example, octyl ethanoate is used for oranges, phenyl ethanoate is used for bananas. So I'll be showing you all an equation of the esterification process in making the aspirin. Firstly, salicylic acid and acetic anhydride are combined together, which forms acetyl salicylic acid and acetic acid. Acetyl salicylic acid is the aspirin that we need to obtain by combining those two reactants. So, acetic anhydride is an esterification agent which is used in the process. Yeah, it has multiple uses also. For example, the preparation of modified food starch and conversion of cellulose to cellulose acetate. So here, as you can see, is a chemical structure of the acetic anhydride. So during the esterification process, the acetic acid, which is soluble in water, and yet the aspirin is not. So when aspirin is mixed with water, it will precipitate out. Yeah. After the esterification process, the aspirin that we obtain is called the crude product. After obtaining the crude product, it is dissolved in hot ethanol and is then recrystallized to form a pure product. Now I will pass my time over to Gabriel.
Thanks, Hunter. Okay, so I'll be talking about the recrystallization process, the melting point, calculations of a percentage yield of aspirin in this experiment, the chemicals used in the experiment, and the apparatus used in the experiment. Okay, so first I'll be talking about the recrystallization process. So what is recrystallization? It's actually, regardless of whether it's about this experiment, it is a method of purifying an impure compound in a solvent. So what is the temperature that you would use for recrystallizing the process? The temperature of the solvent that you should use should be a higher temperature, and so that more solute can dissolve in the solvent so that you can recrystallize the product. Okay, so what is a solvent to use? What solvent should you use? So actually, water will be a very good solvent to use because it's actually very safe and it's very cheap. However, we cannot use it in this experiment because it partially decomposes. So a solvent that we use is ethanol, as it does not decompose and is relatively safe too. So it's used as a solvent instead of water. Okay, so what is melting point? So now I'll be talking about melting point. So a melting point is actually the temperature at which the solid changes into liquid state, and then the solid state and the liquid state both exist in equilibrium. So how is melting point important? So it's actually a very important physical property of any compound. So it actually can be used to determine a substance. For example, if I have an element that have like a certain boiling point or a certain melting point, then I have a compound that I want to test whether it is that element. I can test for its melting point, and if it does match the melting point, then it will be used to determine that it is that element. So melting point, furthermore, it can also be a sign of purity of the substance. So for example, a pure compound will actually melt over a very small range of about 0.5 to 1 degree Celsius, and if the melting point range of a compound is actually a very large, such as 5 degrees, it would melt over a very large melting point range, like for example 5 degrees. Okay, so how do we determine the melting point of in this experiment? So firstly, we need to find out the theoretical melting point of the aspirin, and so the theoretical melting point of aspirin, as we found, was actually 183 to 140 degrees Celsius. 138 to 140 degrees Celsius. And so we are going to we have a compound in this experiment, and so we are going to test the melting point of the compound to check if it matches with melting point of aspirin, which is 138 to 140 degrees Celsius. So if the melting point of the substance that we are using in the experiment matches the melting point of aspirin, it's actually pure, and you can confirm its identity of it being aspirin. Melting point equipment is actually used to test the melting point of this used to test the melting point to ensure that it's aspirin. Okay, so I will now talk about how to calculate the percentage yield. So what is percentage yield? Percentage yield is actually percentage yield is the yield that you get from the end of the experiment. So supposedly you're supposed to get 100% yield. However, all experiments you will be unable to get 100% yield due to issues in the whole experiment, like such as you wash the crystal with too much water or too little water and such. So how do you actually calculate the percentage yield in this experiment? So to calculate the percentage yield, you actually find the mass of the pure aspirin that you have, the pure aspirin, which is the actual yield of aspirin that is given to you. So then you use this value, and then you divide it by the theoretical yield, which then you multiply by 100% to find the percentage yield. And so supposedly, if actually all these processes in this experiment were done correctly and were done accurately, such as using the correct amount of solvents and like 5 ml, you really go and measure 5 ml to make sure that it's very accurate. Actually, the percentage yield should be very close to theoretical yield, which is 100%. We are going to find out if our experiment is close to the theoretical yield. Okay, so the chemicals that we use in this experiment were actually, to make the aspirin, we use salicylic acid and acetic anhydride, and some other chemicals we use were actually distilled water, ethanol, and concentrated sulfuric acid. So, for example, whole distilled water was used to wash the crystals to make sure that wash the crystal for suction filtration to make sure that it was properly really clean, and then to prepare for suction filtration, you also wash the crystals with you wash the funnel with cold water to make sure that none of the solvent actually passed through the Bushnell funnel. Okay, so the apparatus we used were conical flask, glass rod to stir, filter paper during the Bushnell funnel step, and then the suction filtration setup to filtrate and get the crystals pure and impure. We use a nitrile gloves, a measuring cylinder, a water bath to heat to dissolve the crystals, a watch glass to contain the crystals, a plastic dropper to drop the amount of water and, for example, chemicals. We use a balance to weigh the mass of the watch glass with and without the crystals. We use a hot plate to heat it to ensure that it properly dissolves, a desiccator to dry it, oven to remove the water moisture, and melting point equipment to test the melting point. So how did we prepare aspirin in this experiment? So the first step that we did was actually to weigh 2.4 grams of salicylic acid, and then we added 6 ml of acetic anhydride to the salicylic acid. So just now I was talking about percentage yield. So for example, in these steps, like step 2, where we use 6 ml of acetic anhydride, we actually use a dropper to measure the 6 ml and make sure that we were very accurate with the 6 ml to get as high as a percentage yield as possible. So we followed by 3 drops of concentrated sulfuric acid into the mixture, and then we heat it for 10 minutes using the water bath. Afterwards, 1 ml of distilled water was used. Likewise, we used the dropper for step 5, and then followed by 40 ml of cold distilled water. And then we used suction filtration to actually collect the crude product. So the recrystallization of aspirin and melting point determination. So what are the steps that we use to find it? So firstly, we dissolve the crude product in ethanol for the step of recrystallization. Then we followed up by 30 ml of hot water that we added into the mixture, and then we warm the solution using the water bath using a hot plate until the solid dissolves. The solution was then cooled down to allow the crystals to recrystallize. The recrystallized product was then obtained through suction filtration. We allow it to go through a second suction filtration to ensure that it actually to remove all the ethanol and all the other liquid inside to get the crystals, and then the product was dried in the oven to remove moisture content in the crystals, and we also use the desiccator to ensure that it dries without any humidity in the air, and use the melting point determination to determine the melting point equipment to determine the melting point of the crystals formed. So now I'll pass my time over to Fumi.
Okay, thank you, David. Okay, so we're talking about results, discussion, conclusion, and recommendation. Okay, so basically the start temperature and the stop temperature is the temperature we set in the melting point equipment. And for the results obtained of the melting point range is 137.6 degrees to 140.1 degrees Celsius. And for the second trial, the results obtained for the melting point range was 138.1 degrees Celsius to 139.8 degrees Celsius, which is also mean our results obtained were accurate as it was within the 0.5, it was within the plus minus 0.5 range. Yeah. Okay, so the start weight is basically the weight of one watch glass and two filter paper, and the end weight will be the watch glass, two filter paper, and the aspirin. So by subtracting the end weight and the start weight, we will obtain the weight of the aspirin. So for our percentage yield of aspirin, the results obtained for us was 44.8. The percentage yield was shown here, and for 44.8 is quite low as it is expected to be as close as possible to 100, as the expected mass was 2.61 grams, but because it's 44.8%, so we only obtained 1.17 grams for the aspirin. Okay, so the expected mass is supposed to be 2.61 grams, as this is the formula to calculate the mass, and the mole is given by the lecturer, that is 0.0145 mole, and the molar mass is 180 grams, which can be obtained in the periodic table. So by using the formula, we can find out that the mass we are supposed to get for the aspirin is 2.61 grams. So for our melting point range was quite accurate, as we only did as it was within the plus 0.5 range, but there could be some experimental errors in some other experiments, because maybe there could be a misuse of laboratory equipment, or maybe too much or too little chemicals was added inside, and maybe the timing is not accurately gauged. Like for example, if it's supposed to be 5 minutes, maybe like a stopwatch could have been used, or a timer could have been used. Yeah. Okay, so there's a lot of shape and sizes of aspirin, but the most common type of aspirin is shown here, and our shape was correct, as the results for our aspirin is needle-like, white in color, and were very brittle. Okay, so this is a percentage yield formula, and yeah, because the amount of percentage yield obtained by us is 44.8, so the percentage yield was rather low, and the results obtained could have been higher if more time was given, or if phosphoric acid could have been used, as phosphoric acid is a better substitute, but it is a very dangerous chemical, so maybe that's the reason we did not use it. Okay. Warm water could have been used instead of boiling water, as boiling water needs more time to cool down. So by using warm water, the experiment could be done faster. And do not overboil the solution, as overboiling may cause the yield of the aspirin to be low. And cold water could have been used in suction filtration, as by using cold water, you will make sure the aspirin do not stick to the Bushnell funnel. So if cold water is not used, if you stick to a Bushnell funnel, then the percentage would be lower. and aspirin crystals must be dry in a desiccator before weighing, as if it's not dry properly, the aspirin you could have water droplets in it and could affect the weight. Okay, so now talk about conclusion. Okay, so the objective of the experiment is to synthesize purification and characterization of aspirin. The melting point obtained for our experiment is 138.1 degrees to 139.8 degrees Celsius. Next. Okay, the theoretical yield of aspirin is 138 degrees Celsius to 140 degrees Celsius. Melting point obtained was within the range of plus minus 0.5, which is why our results obtained was very accurate and is high in purity. So the percentage yield of aspirin for our experiment was 44.2. It is not satisfactory as it could have been higher if more time was given, but generally the results were met.
Do you have any questions? Okay, thank you.